Hello everyone. Today we're going to learn a lesson on electric field and charges. Chapter 1 of Physics, Class 12. So, what is electric charge? In electric charge, there are two types of charges. One is positive and second is negative. And the unit for electric charge is coulombs. Here we can see two diagrams. One consists of an electric field from an isolated positive charge, and the second one consists an electric field from an isolated negative charge. Next is the basic properties of charges. There are two types of charges, like charges and unlike charges. So what are the properties of charges? There are three types of properties. One is conservation of charges, second one is quantization of charges, and third is additivity of charges. So the first one, conservation of charges. The total charges of an isolated system is always conserved. Initial and final charges will be the same. To put in simple words, total charge of an isolated system remains unchanged with time. As for the second one, quantization of charges, the charges always exist in an integral multiple of fundamental charges. Or you can say the total charge on a body is always an integral multiple of a basic unit of charge denoted by A and is given as Q is equal to plus or minus NE, where N is an integer and E is equal to 1.6 into 10 raised to minus 19 coulomb. The third is additivity of charge. If there are n number of charges present inside, the total charges present will be algebraic sum of individual charges. So the formula is Q is equal to Q1 plus Q2 plus Q3 plus so on to Qn. Here the total charge of a system is the algebraic sum, that is the sum of taking into account with proper signs of all individual charges in the system. Next is electric dipole. Now what is electric dipole? Every dipole is associated with a dipole moment vector P whose magnitude is equal to the product of the magnitude of either charge, which is Q, and the distance 2a, that is vector A, between the charges, that is vector P is equal to Q into 2 vector A. Now what is the electric field due to dipole? The electric field due to dipole is based on two things: on an equatorial line or an axial line. On the equatorial line, that is broad on position, E is equal to 1 by 4 pi epsilon into P by R cube. As for the axial line, that is end on position, E is equal to 2P by 4 pi epsilon R cube. Now next is Coulomb's law. What is Coulomb's law? Coulomb's law states that the electrostatic force of attraction or repulsion between two stationary point charges is given by the formula F is equal to 1 by 4 pi epsilon 0 Q1 into Q2 by R square, where F denotes the force between two charges Q1 and Q2 separated by a distance R in free space. Epsilon 0 is a constant known as permittivity of free space. The free space is vacuum and may be taken as to be air practically. Also, the formula 1 by 4 pi epsilon 0 can be written as 9 into 10 raised to 9 Newton meter square by Coulomb square. Now using superposition principle, that is the total force on charge due to other charges will be equal to the sum of individual forces, that is vector F total is equal to sigma of vector F. Here there are 2 points to mark. The vector sum of forces would give us the total force. Second, force between two charges is unaffected by the presence of other charges. Next topic is electric field. Now what is electric field? Electric field intensity at a point distance r from a point charge q in air can be written as vector E is equal to 1 by 4 pi epsilon r square into r vector. So, what are the basic characteristics of electric field lines? There are three types of characters. Field lines start from positive charges and end at negative charges. Electrostatic field lines do not form any closed loops. And last, the two field lines can never cross each other. Next is electric flux. Electric flux refers to the electric field lines that penetrate a given surface. For a given uniform electric field E passing through an area A, the electric flux is defined as phi equal to EA cos theta. Electric flux over an area in an electric field represents the total number of electric field lines crossing this area. Next under this is Gauss's theorem. The total number of electric flux over a closed surface S in a vacuum is 1 by epsilon 0 times the charges contained inside the surface. Hence it can be written as phi E is equal to closed interval of vector E dot d vector S also can be written as q by epsilon 0. Or it can be written as the net flux through any closed surface S equals the net total charge inside that surface divided by epsilon 0. Next comes the applications of Gauss's theorem. There are three types of applications: volume charge density, surface charge density, and linear charge density. Here volume is represented by rho, surface is represented by sigma, and linear can be represented as lambda. Here lambda is q by L, sigma is q by A, and rho is q by V. As we can see in these three types of charge densities, volume means the charge is distributed evenly throughout a volume that is represented by V. Hence the volume charge density is defined as P equal to Q by V. Units are coulomb by meter cube. Surface charge density: when a charge Q is distributed evenly over a surface area A, the surface charge density is defined as sigma equal to Q by A. Unit is coulomb per meter square. As for the last, linear charge density, when a charge Q is distributed along a line L, the line charge density is defined as lambda equal to Q by L. The units are coulomb per meter. This is the end of the lesson. Thank you for watching. Please subscribe, share, like, and comment. And don't forget to click the button. Bye bye.